So we're going to spend today and tomorrow learning about inequalities. I hope you were able to get a little bit of work done on that assignment that I put on Canvas yesterday. I think I said that it was nothing that I needed you to get done. It was more of just an introduction so that today goes a little bit smoother. Teaching equations takes a long time. Teaching inequalities, thank you, takes very little time because you know now all the fundamentals of how to distribute, when to add 6x to both sides, stuff like that. So there are two new things, only one of which is going to come up today, but I may throw in a little extra something. The trouble with the assignment I'm going to give you is I did elect to do delta math today because I thought it would be convenient. But I'll say this again in the lecture that the X for this assignment is always on the left, and I kind of hate that. So anyhow, let's get to it. So today is the dreadful day. It's a date that I never, ever get any satisfaction out of writing down. And we're going to start solving inequalities. So you know what inequalities are. They're like equations in that we're comparing a left side and a right side. When you have an equation, the left side equaling the right side is a very powerful thing to say. It means all the stuff over here is exactly the same as all the stuff over here. With inequalities, we don't use the symbol equals. We use symbols like this. And what does that say? Like, read that to me out loud. Yeah. Like is greater than or is more than, right? Something like that. So it's a comparative statement that we use when things aren't necessarily equal to each other, right? Like 6 is greater than 2, something like that. What is this symbol if I put a little line under it?
It's either greater than or equal to.
Greater than or equal to. So that, the first symbol that I wrote, there is no possibility of them being equal to each other. It's not allowed. But the second symbol brings in the possibility that the one on the left is either bigger than the one on the right, or they could equal each other, right? So bless you again. So that's what we bring into play with that little line, is the possibility of things being equal to each other. And then we have the signs that point the other way. What's this one? Is less than. And then same idea, we can bring in this little extra bonus. Right. So those are your 4 inequality symbols that we're going to be working with for the next, I don't know, few days or so. All right, so let's get into it. What we're going to learn how to do is solve them and graph them. And Delta Math has a really nice graphing feature. It's, I think, why in the end I wound up choosing to use it today, is because I do like the graphing interface when you're first getting started. So here's your first example. You know by now, this is how I teach, right? This is what we're doing. Let's do some examples. So our first one is this. And again, if this were the land of equations, then we would be worried about what could I put in place of X to make the left side equal the right side. I'm not about that now. First off, would you agree that if I changed X into like 1,000,000, that it would be true?
Yeah.
Like 3 times 1,000,000 is 3,000,000, and add that to 12. Is that answer bigger than -3? It is. If Josh was like, boy, whoa, simmer down there. Let's say Josh just put in like 1 for X. Does it work?
Yeah.
Yeah, because 12 plus 3 times 1 is 15. So you get the idea that, so here right away is a big thing that's different. With equations, we get one answer. X equals 2. X equals -4/3, stuff like that. With inequalities, we have infinitely large sets of numbers that are solutions. We're not looking for a number. We're looking for a set. So having said that, let's solve this and take a look at what the answer looks like. Just like we do with equations, what would you do first?
Try to get the X by itself.
Right. I mean, that's always the goal, right? So what would we do first? We would subtract 12 from both sides. The mechanics are no different. And then I'm going to bring down my 3x, and I'm going to bring down my greater than sign. And I'm not going to do the math wrong. I hope we're all getting to that point where we realize how crippling this is. If you're someone who misses these, I hope you're starting to feel the burn and maybe feeling like, I want to get better at this. What's -3 minus 12? Yeah, all day long, it's -15, right? And then what do?
Divide 3.
We divide both sides by 3, just like we would with an equation. And then we bring down our X and we bring down our sign, right? And then we get -5.
X is greater than -5.
Good. Now let's be clear about what that means. Again, it's not an equation. That doesn't mean that the answer to this problem is -5. It means that literally any number that's bigger than -5
Could be
could be X. It could be -4.9. It could be -2, -1, 0, 1.3 repeating, 56.2, 929 trillion, anything. So the question becomes like, how do I express that? Well,
You put the dot on the number line, we put it anywhere to the right.
nice job, Justice. And so get used to doing this. And the delta math is going to save you a lot of work on this. When we do it on paper, we have to draw the number lines ourselves. However, I'm not one of those guys that need you. I'm not one of those teachers that need you to draw a number line and label like 10 things. I want one thing. And you're going to come to know this point right here. You're going to hear me say this a lot as the boundary. All I'm interested in is the boundary. The boundary is the number where the numbers on the number line go from being lies to truths. So first off, let me ask you this. Is -5 a solution of that? It is not. For reasons we discussed earlier, is -5, if I put it right there, is -5 greater than himself? That would need an equal sign. So like as a math person, I say, well, God, how do I make my graph communicate that to somebody? Like this. You put a circle on -5 and you do not color it in. You make it big enough that everyone can see that it's open, we call that. So by putting an open circle, you're telling someone that this is where the boundary is, but don't count this number. And like Justice said, where are the numbers on the number line that are bigger than -5? To the right. Remember, to go bigger than something, you have to go to the right. And the way we show graphs is we just put some shading and draw a big obnoxious arrowhead like that. And that's how you tell the world that anything to the right of the circled number is a solution. Let's practice again. Everybody okay? Okay. For my next example, writing these down will help you to remain more engaged. It's less boring if you write things down. It goes quicker. What do we do first? We add 15 to both sides. And I will say, based on how good your quizzes have been, I'm loving grading most of them. We're getting closer to that point that I promised you about, where we're going to stop needing to show quite as much work. And that should be really good news for some of you. Some of you look right at this and already know what I'm about to write in white without having to show the stupid work, right? Like you already knew it was going to be that. And so the good day for you is coming where I'm going to pull back my reins a little bit and say, it's okay. Now, what do?
You divide 4.
We divide both sides by 4. And then we get y is what?
Is less than or equal to 6.
Couldn't have said it better myself. And you said it nice and loud. People on the recording could probably even hear that. That was great. So there it is. That's my final answer. And now, again, the question is, that's an algebra answer. That explains it mathy. How do I make a graph that shows someone that? Well, I start with a little number line, nothing fancy. Always put arrows on both sides, just little arrows, because it's a line. And what's the one number I need?
6.
You bet we want that boundary point, and I'm going to circle it, but what am I going to do? Yeah, this time I'm coloring in my circle, and I'm making sure everyone knows that I colored in my circle, because I want them all to see that I'm trying to show you that +6 works, right? He counts. He's less than or equal to himself. And where are the numbers that are less than him?
On the left.
Less than is always to the left, provided that our variable's on the correct side, just like that. Now, I'd love to end the lecture there, but I cannot, because there's one thing I wanted to check off my to-do list today, and it's these next 2 examples. Do you have any questions so far? Just like equations, right? All right, so here comes example number 3. This time, I'm going to try an approach in teaching of not talking to you while I do this problem. I am actually going to solve this problem on the board, and I solemnly vow, I am not going to make a mistake. There's going to come a point where you're going to think that I did, and that's going to be the discussion that we have to have. Ready? Here I go. And having never learned the rule, you would look at that logically and say, I think my math teacher might be losing it. Shouldn't that be a blank? Do you see what I did?
You flipped it.
Yes. And if you're paying attention, you noticed right away that Mr. I'm not going to make a mistake, took the is less than sign. I told you I'm not going to make a mistake. Why did I do that?
Is the negative
What's a negative?
the 5?
The number I divided by is a negative. So this somehow goes in your notes. There's not a lot to learn about inequalities, but this is a big one. If you multiply or divide by a negative, you got to flip your Pac-Man. Pac-Man goes from Waka Waka-ing to the east, and he whoop, whoop, turns around and Waka Waka's back to the west. And that's not like something that I'm making up. It makes sense because negatives change the signs of the numbers. So it should also have to change the sign of the comparative statement, right? Doesn't that make sense?
Yeah.
So what you just learned, and I hope you got it either in your brain or in your notes or both, is that when you multiply or divide by a negative number, Pac-Man does the flipperooski, right?
Yeah. Okay, that makes sense.
I'm glad to hear that. Let's graph that little bad boy. Let's make ourselves just a tiny little simple number line, throw some dumb arrowheads on there. What number do I need? Yeah, that's my boundary. What kind of circle am I going to make? Open. Good job. And which way will I shade?
Right.
To the right, because in my final statement, m is greater than -5. And the numbers that are greater than this guy are to his right, like this. Let's do one more example just to make sure that that point set in loud and clear. We will have more notes tomorrow, and I will make the problems, they'll get more difficult tomorrow. Today's like our kind of little foot in the door, introduction. So here we go. Next one. You can see why we do equations before inequalities, huh? That makes this pretty breezy. What do we do first?
Add 10.
Yeah, let's add 10 to both sides. And just to give you a sneak peek of where we're headed as a class, you ready for this? Don't do this yet. I'm just showing you what I mean.
Yeah.
I'm going to start allowing some of you, if you prove to me that you cannot mess it up. Do you see how I didn't show my work? I added 10, didn't I?
Yeah.
Good. So that's kind of where we're going to, some of us get to. There are some people who continue to show their work all the way through Algebra 1 and through Algebra 2, because they're like, if I don't show it, I mess it up. I put -62 like a knucklehead, right? So anyways, I'll put it here now just so you can see. Yes, I added 10 to both sides. I just elected not to show it. What do we do now? Divide both sides by -6, and the red flag goes up. That, just hearing you say that, you go ding, you ring that bell. Pac-Man's taking a flipperooski, isn't he? So what's my final answer? Less than or equal to? Jackpot. You look at the original problem and you think your shading on your number line is going to go to the right. And then you get to the end and you're like, well, it actually flips and goes, my shading goes to the left. Weird, right? That's what negatives do. Negatives are funky little monkeys, man. Yeah. Let's make a little number line, and then I'm going to show you what this looks like on Delta Math, and then kicking some butte here today. What number do I need? What kind of circle will I make? Closed. Color that bad boy in. Right.
Going to the left.
And we are going to the left, you bet, because it says less than. All right, so let me pull up Delta real quick. I already got it fired up and ready to go. So here is a math problem on Delta Math that you will be working with. Let me zoom in on that just a little bit. Don't have your Chromebooks out quite yet because I really want you to follow along and then because I don't want to have to explain all this again. So here it goes. So I'm just going to write right on the board here. What would I do first on that problem? I'm going to add 3 to both sides like this. And I'm going to get negative 5x is less than or equal to what? 40. And then what will I do?
You divide by -5.
I will. And when I hear you say that, you bet Pac-Man's going flippy do. So I get x is what?
That's under.
Greater than or equal to. So in the inequality notation box, I'm going to type in here, I'm going to type in x, and I'm going to choose the greater than or equal to sign, and then I'm going to type in -8. Now, the number line is pretty slick. You see how it's all ready to go? So tell me about my number line. Where's it going to start?
-8.
Okay, so I'm going to go to -8 and I'm going to click. Now, if I just click there, nothing happens. But if I click and drag, look what I'm doing. I'm making a line. Which way?
To the right.
To the right.
I want to the right because my purple answer says greater than. Now, if I stop here, do you notice how the green dot is still a circle? But check this out. If you go all the way, boom, turns into an arrow.
Oh.
Do you like my circle closed in?
Oh, yeah, wait, yeah. Yeah.
You should. If I didn't like it, all you got to do is click on the circle. It's pretty dope. So you click it, boom, close, click it, open, closed, open. It's pretty slick, man. So you go, you go to your spot, you drag till it's an arrow, change the circle if you need to, and then you hit send. And that is how slick it is on Delta. So you're still doing the problems on paper, but all the stuff you're doing in here is pretty slick and easy. Good. So here's what I'd like you to do. I'd like you to get your Chromebooks out. We have about 5 minutes, and I'd like you to set a goal and say, maybe I could get 3 problems done before the end of class today. Huh?
Yeah.
I think you can do that. And you do not need to worry about getting it done today. I'll just add into it tomorrow. We can have a work day tomorrow after the notes. So